welcome to our webinar Wednesday series. I'm Dr. Keith Bramwell with Jamesway. Carolina Diaz, you can see on there, she's also one of our consultants. She'll be kind of helping with the Spanish side a little bit. So as usual, we have a question and answer box at the bottom. We're going to do a little bit different this time. If you have questions, we're not necessarily going to wait till the very end to do questions. If you have some in the middle, you know, we may go ahead and ask Jerry at that time, because we're going to kind of have this, it'll be a little dialogue discussion thing rather than just a straight let Jerry talk for a long time. So a little bit different than what we've normally done with that. Question that always comes up as well is if you're going to get a copy that, yes, everybody will get an email that's registered. They'll have a link to the recorded version of it that they can look at this at a later time. So just getting some of that housekeeping out of the way. And if you want to hear it in Spanish, there's a little Spanish translation box at the bottom, interpretation box. And Carolina, you want to let people know where that is in Spanish?
Okay, sir. Buenos días, buenas tardes a todos. El webinar de hoy va a tener una dinámica un poco diferente. Vamos a poder hacer las preguntas a medida que va transcurriendo el webinar. Entonces no vamos a esperar hasta el final. Si ustedes quieren, en la parte de abajo, en la caja donde aparece un signo de interrogación de Q y A, pueden escribir sus preguntas y las iremos respondiendo conforme avanzamos. Adicionalmente, vamos a tener nuestra traducción simultánea en español. Pueden oprimir el botón que está en la parte inferior, donde tenemos un globo o un mundito, un círculo, y ahí nos da la opción de irnos a la parte de español. De todas maneras, vamos a grabar este webinar, y para todas aquellas personas que se inscribieron, irán a recibir el link con la grabación del webinar. Esperamos que disfruten de este webinar diferente.
Okay, thank you, Carolina. All right, so it is my pleasure to introduce Jerry Garrison. He and I kind of go way back. He was kind of a mentor to me as I was doing some work with Jamesway when I was still at the university. And we've always had a good time speaking at meetings before each other, after each other, and ribbing each other. So we're going to try not to do too much of that today, but we'll probably do a little bit. Jerry's got about 50 years experience in the industry. Started out as a hatchery manager in Mississippi, where he still lives, and then joined Jamesway, and about 25 years with Jamesway, something like that. So a lot of experience. Those that have been around the industry for a while will recognize Jerry. He's most of the things that we do within Jamesway profiles and all that stuff coming back from some of the work that Jerry did, as we're really transitioning into more of the single stage. So it'd be good to hear some of his discussions and thoughts on things. And so with that, we will go ahead and let Jerry start with this. And again, like I said, we will have we'll do some questions intermediately if we have some. And let me share a screen here. Okay. All right, and I'm going to stay on here this time instead of canceling my video, because we're on the same video screen.
Okay.
So
You do.
Go ahead, Jerry.
Okay, first of all, thank y'all for attending the webinar, and thank you, Keith, for inviting me back. It's been a few years since I've been in the industry. I think I retired in 2018, and since then been in contact with some of y'all customers, and it's been my privilege and an opportunity to be in the poultry business. Tell me to scoot back. With that said, let's just get started on some basic stuff here. Yeah, I wanted to start by just I was always as I was in the industry and working with Jamesway and transitioning through the different phases of multi-stage to the single stage and that kind of stuff. The embryos, you know, is actually is the embryonic development, you know, is some basic things that's needed, what is required for incubation, and all of actually all of the presentation is based on these 4 points in the basics of incubation. The first basic I left to mention is the heat. You know, that's the temperature or the operating parameter in relationship to the heat of the embryo. And I always said it's the driving force that establishes, maintains, and controls embryonic development. You know, as we look at the embryo, the embryo in its early stages of development needs heat to kick off or to start the incubation process. As the eggs go into the incubator, they need heat. And, you know, humidity is not the big issue at this time, but the heat is the driving force for that embryonic development. And if you put too much heat on the embryo at the beginning, it will accelerate your hatch, you know. And if you looked at the heat in relationship to the embryo, it's actually 3 phases or 3 stages of that thermal heat. The endothermic stage, which would be in your first week, your neutral stage, which would be in your second week, and then your exothermic stage, which is your final stage. But each one of these stages require different. So at the beginning, in the endothermic stage, you will need heat. You know, you need the heat to start the embryonic development. You'll need the heat to maintain that embryonic development at the correct speed. In other words, at day 1, day 2, day 3, day 4, 5, 6, 7, you know, the heat is needed. And as the embryo begins to develop during that neutral stage, is really sort of like the word says, it's neutral in relationship to heat. You know, it just needs the correct air temperature to maintain the embryonic development. And then the third stage of it is exothermic, when the embryo begins to produce heat. And, you know, the embryo needs cooling at that stage because it's producing heat. So it needs cooling, it needs oxygen, you know, it needs proper ventilation outside the machine, and it also needs proper inside the machine. The second thing is humidity, and I just got down here, it controls moisture loss, but it does more than just moisture loss, especially in the multi-stage machine. About 70% of the cooling is associated with the spray, and 30% to the cooling. And in the single stage, it's sort of a reverse figure of that. It's about 70% air cooled and then 30% spray. Okay. And then we'd look at the airflow. The airflow takes the heat and the humidity and makes creates the correct air movement through the egg pack to obtain, maintain, and distribute the correct air temperature and humidity to achieve and control the embryonic development. So the airflow is very key, and you know, and it's something that it needs to be a uniform airflow where every embryo will get the same opportunity in relationship to the temperature or the heat and the humidity. The fourth thing we mentioned is turning. And of course, the purpose of turning in regard to the basics of incubation, it properly orients the embryo during the early stages of embryonic development. We'll talk later about each one of these in more detail, but the turning in our single stage machine, basically we stop turning at day 14, and then from therefore, you know, we don't turn. But in the multi-stage machine, it serves really a different function. It also in the single stage machine, all the eggs are turned or oriented in the same direction, and in the multi-stage, each one or each side, A, B side, however you want to say it, but one will be turned to the left and one will be turned to the right, and that's very key in relationship to the way the air moves. And people have asked, can we turn them all the same way in the multi-stage? if you do, you'll have to change your fans, because all the fans in our multi-stage machine rotate in a clockwise direction. And as the eggs turn in the reverse direction, one side is a little bit more restricted, but that corrects every hour as the eggs turn, and it creates that average. You know, when we talk about multi-stage is just a series of averages, you know, where single stage is more specifically profiled to meet the needs of the developing embryo. And another thing that I've got listed, also important, is the damper. The damper controls the oxygen and the CO2. And also in the multi-stage machine, you know, the damper or the air is 30% of the cooling, whereas in the single stage, that air is about 70% of the cooling in relationship to the position of the damper. You might say, well, why is that so important? Well, at the beginning of incubation, you know, but the damper controls the oxygen and the CO2. At the beginning of the incubation cycle in single stage, we keep the damper closed for about 10 days, let the CO2 build up, you know, and it has a influence. And Keith, you might want to elaborate just a little bit on what we talked about on that.
Basically, by keeping the damper shut, it creates a slightly hypoxic environment. It's a little bit low in oxygen form, so the embryo has to try and survive. So physiologically, it grows a little bit better cardiovascular system to survive, and then when it gets back into a normal setting, it's more efficient in how it operates.
Good deal. And then, of course, the oxygen, we all know at the end of incubation, all embryos need oxygen in order to survive. And, you know, then you think about where does oxygen come from? It comes through a proper ventilation system that introduces fresh air into the room. And then from the room, the fresh air is injected into the, is taken in through the damper. And that's where we get the oxygen needed at the latter stages of embryonic development.
Oh, look at that. We're having technical difficulties already. There we go.
We talked about the requirements for incubation, but you know, one of the things, your machines also need some basic stuff, especially with these modern controls and all the electronics involved in the makeup of the control of the machine. There's some basic inputs that the machine requires, and if you do not provide these properly, then the embryos inside the machine will suffer, and also the efficiency and performance of the machine will suffer. So I've got these listed as, first of all, we need good, stable, reliable electricity. I remember some cases where that wasn't true, and we had some variations in the electricity incoming into the hatchery, and never could keep the machines calibrated. The complaint was that machines is continually out of calibration, and come to find out it was related to improper electricity. And then the good quality water that meets the correct criteria. Being as in the multi-stage machine, it's 70% of the cooling is attributed to the spray or to the water. We can see why that is so important, you know, with the spray nozzle spraying properly and all these different things. But in the single stage machine, it's basically the same thing, although it's not as much influence in relationship to the cooling. Also in the Jamesway machine, we need good, clean, dry, compressed air that meets the correct criteria. And all of the racks or loaded racks are turned by air. And if you got, like example, if you got water or oil in your airline, it's going to go to your cylinders, and it's going to cause a malfunction in relationship to your turning. Also, good ventilation that properly supports the embryo and the machine. So the machine needs proper ventilation for its to operate efficiently. The embryo needs proper ventilation in order to develop and provide the with the damper closed, the CO2 with the damper open, the O2 or the oxygen. Another thing that the machine does or needs is good egg pack that meets the correct criteria. I've heard just in talking to Keith and different ones that the egg pack today is challenging to say the least. You know, with the fertility and being down, we have discussed that people are taking and molting the breeders and up to what do you say, 80?
Yeah, there's one that's 80 weeks of
80 weeks.
big eggs.
So what do you do? If the egg pack is not correct, don't expect your hatch to be as good as it's supposed to be. An example of that being, I heard that the fertility in the U.S. and is it all over the world?
More so in the U.S.
More so in the U.S. that our fertility is 3% less than it should be. Now,
sometimes more even. It's a challenge.
Yeah, it's challenging. The fertility is a challenging issue. And let me tell you one thing, you cannot hatch an egg that's not fertile, and then fertile egg will not hatch, It takes up the space, but it will not hatch. It must be fertile. And if you've got a 3% lower fertility in the U.S., you naturally will have a 3% lower hatch. It goes hand in hand,
Yeah.
And again, I've got listed along with good management and maintenance, in other words, the way you manage your hatchery is very crucial in the way that the machines perform or the output of the machine. And the statement I've always made about maintenance is no hatchery, regardless of its age, is any better than its maintenance program.
Absolutely.
I've been in hatcheries 40 years old and they looked like they was 10. I've been in hatcheries 10 years old and they looked like they was 40 years old in relationship to the maintenance and the different things that's required in the maintenance. So again, you can't expect the machines to perform if you don't have the basic stuff right or the basic inputs right. You can't expect the machine to perform efficiently if you hadn't got the basic inputs to the machine correct, and you cannot expect proper embryonic development with improper conditions being supplied to the machines. And again, it all goes back to heat, humidity, airflow, and turning. Those things are what we look at. Is that going too fast?
No, I think again.
What about in today's industry? I know when I was still in the industry, some of the challenges that the hatchery managers face and was the egg pack, uniformity of the egg pack in relationship to egg size, larger eggs, more heat generated by the new genetics and stuff. All of this presents a challenge that makes the hatchery management or the hatchery managing the hatchery more challenging, to say the least, of the different things that we've been introduced to as a relationship to the changes, and all of it boils down to one thing: the pounds of meat that goes through the processing plant. It's changed the way that we manage the hatcheries. I remember when I first started, in genetically speaking, one of the primary traits that was desired was the hatchability and high fertility and hatchability. As the industry has transitioned, the main purpose or the main objective, the main goal would be or is to get more meat to the processing plant, and there's relationship in regard to that, the challenges in relationship to the viability of the embryo. I would say that just I guess a blanket statement would be that the embryo is less viable today than it used to be. So again, hatchery managers, pay attention, get the details correct, get the basic stuff right, and then, you work with what you've got in relationship to the input of the egg pack. And, but the more you know about the machine, the more you will know about how inferior or non-standard the egg pack will affect the overall performance and the efficiency of the machine. Again, smaller eggs, less restrictive. Larger eggs, more restrictive.
Yeah.
So again, the size of the egg and all of this, and the inside that egg, that little embryo is more susceptible in relationship to improper conditions, which will cause it more mortality.
Yeah.
And as I remember, Keith, as we were doing breakouts, we had a graph that showed, that the first early embryonic development, you're gonna have some.
Yeah.
And as the embryo transitions into that neutral stage, it's pretty well kneel in the middle, but then you've got that spike over here on the latter stages, So again, early and late mortality is expected, but what is the expectations in relationship to that?
Right.
You don't want the 6% early and 10% late.
All right.
Needs to be something like about a 94% hatchery fertile. Would that be a good number?
Probably what I look at is total embryo loss in a prime flock that's all good, be about 5% normal that we can't get past. I mean, that's biological loss. Once we get above that, then we can start tagging what was causing it.
Absolutely. And it depends on whether you got early mortality being out of kilter, or you have got, sorry about that word, but or if you've got late embryonic mortality, as you attack the problem a different way.
Absolutely.
So you look at the needs of the embryos. We've already talked about the heat, humidity, airflow, and turning. At the early stages, they need heat, CO2. They need turning. All at the beginning. At the end, they need cooling, oxygen. And less humidity. Okay.
Yeah, this last one, I want to know what you found fun in all your years.
Oh, yeah. What's fun
for you? What have you found fun?
When I retired was probably the funnest I've ever had. You know what I mean?
Oh, come on now. There were some good times in there.
Oh, it was some good times. As I look back on my career, of course, I started in the managing hatchery back in 1974. Actually started in 72, but I had to finish college. And then in 74, actually started in the hatchery and started managing a hatchery, and did that for about 20 something years. And then I went to the broiler side and was a serviceman for broilers for a while. And then for some unknown reason, I started working for Jamesway.
That's when it got fun, right?
That's when it got fun. Yeah, it really did, because I had a little hatchery, electromechanically controlled, small hatchery, and it was challenges, of course. But during the 70s and the early 80s and 90s, hatchability was not really that hard to achieve. I told some people before, back in the good old days, you could put the eggs out in the parking lot and hatch them almost, But that's not necessarily 100% true, but they was real forgiving. And today's embryo is not as forgiving in relationship to these basic things that the embryo needs. But it has been fun, you know, working in the industry, all the places that I've been, and all of the things that I've seen, and all of the things that we do. It's, you know, seeing the industry starts transitioning from multi-stage to single stage, and then here I'm a dumb Mississippi boy trying to figure out profiles and how to make the machine be more efficient, how to make it run. But one thing that I knew more about was the multi-stage, and I took the multi-stage, what was happening in it, and applied it to my profiles that I was making for my single stage machine. And that's where it sort of all begins to tie together. The embryo needs the same thing, you know, regardless of whether multi-stage or single stage. How it gets the same thing is the difference between the two concepts, you know. Like multi-stage, you know, you load with variable ages. You know, every position in the multi-stage machine has a different need.
Right.
But what I've learned about the multi-stage machine is each position supports the next position.
Correct.
You know, in other words, as the embryo is producing at the, say, the sixth position, heat and CO2. I mean, yeah, heat and CO2 as it's developing, that air or that heat and CO2 goes through the egg pack, and as it exits to the youngest embryos, it supplies them with the heat and the CO, you know, the oxygen that they need, you know.
Yeah.
Excuse me, at the first positions, the heat and the CO2 that is needed, you know. And as we think about it in the multi-stage machine, we look at a few things in the multi-stage machine would be like the entrance in temperature. We always, at 24 hours after transfer, we wanted to achieve 100.3 on both sides of the incubator. And then it's at the sixth position, fifth position, you know, we had a set point of anywhere from 98.8 at a while. At the end, we was doing 98.5 and stuff, you know, and as the embryos begin to produce that more heat and stuff, we had to lower the set point and things like that. So if we look at that, you know, the air going through the egg pack in each position, as that air transitions through the egg pack, is one of the places that we began to look at and come up with profiles, you know. Okay.
Mm-hmm.
You want to say anything else about that?
Now, just back to that first one that you talked about, that point on there is the basics.
Yeah.
You know, you got to do the basics. It's hard to go in and make adjustments and fine tuning if you haven't done the basics.
I mean, if you hadn't got the
first.
basics right, you can't fine tune it. I mean, you know,
Yeah.
In other words, you know, if you hadn't got the basics right, you're not going to be right.
Correct. Yeah.
You know, so for in relationship to the embryo and also to the machine, you know, don't expect your machines to perform if you don't input them correctly. You know, don't expect the embryo to develop properly if you don't have the precise environment that it needs to develop in. Okay.
Yep.
Turning during the incubation process. What's the purpose of turning? You know, it's to orient the embryo in the early stages of embryonic development. In the multi-stage machine, we always level the sixth position, okay, because that was the position that's producing the most heat, and by leveling it freed up that airflow to give it more cooling, you know. In the single stage machine, we stopped turning at day 14. And
what are the benefits of that? What do we see as the benefits of that stopping?
The only reason the only reason when we was determining whether to stop turning or not, the main reason was by turning and stopping the position to the left, you know, the air, you know, we'll stop the position like this, like the Christmas tree we talked about. The air is less restrictive as it moves through the egg pack, and it will provide more cooling. Okay. So,
Balances out.
balances out
yeah.
the cycle, and turning is no more needed. Actually, past 12 days, we say we stopped turning at 14, but we've tried it, or have tried it 12 days, no problem. Okay. That we determined, when we're doing it. But the importance of turning is very simple in relationship to the embryo. As the embryo starts developing, and if it does not turn, that embryo will be oriented, and as it starts developing, the embryo will actually stick to the side of the shell. And by about 6 days, if you do a residue breakout, and you've got a lot of 6-day embryonic death, look at your turning, because that's about, it'll stick.
What's the parameters or range in turning? When does it become detrimental to your hatch? If you have a different angle, like what?
Oh, the different angles of turning?
Yeah.
Of course, we always said the multi-stage machine, we always stuck with 45 degrees, but actually 42 to 45 degrees was acceptable in the multi-stage machine. And the way we determined that was simply measuring between the vertical hanging bars, and as the eggs turn, that bar separates, and a 4-inch space or 10-centimeter space was a 45-degree turn. Okay. But I'm understanding now the 41-degree turning is recommended in our single stage machines. And my understanding on that, by turning that less angle with the challenges with the egg pack and the large eggs being tried, it actually, you can get a bigger egg in with that less angle of turning. And it really, I would see no negative effect to it. Also, the turning angle, in other words, I'll go back to the multi-stage. If the multi-stage machine turned at 45 degrees, it creates a restriction through the egg pack. It creates that restriction as the air moves through the egg pack. Okay. If you've got a buggy that don't turn but 35 degrees in amongst that egg pack, what the air will do is coming through, when it hits that less resistance, the airspeed speeds up. Okay. As that airspeed speeds up, the heat that's provided by the oldest embryos, where the air moves through the egg pack, it will overheat that position that's turned, and especially not only that position will it do, the position right behind it is the one that really affected by it, because that airspeed hits that other buggy and it slows back down.
How often should they be turned?
Frequency,
Because you did some work on
Yeah,
that as
yeah.
well and looked at different variables.
frequency of turning, we've tried it at all different times. We even went down to some at 15 minutes. Every 15 minutes, the eggs would turn. 30 minutes, the eggs would turn. But we've stuck to, and I think our recommendation was and still is, and it's every 60 minutes.
Right.
Okay. With 120, in other words, eggs turning every other hour, like at 120 minutes, really didn't see any effect other than the machine, just like the single stage machine, when the eggs are turned this way, the airflow is less restrictive. When they turn back this way, the airflow is more restrictive. So that taken into account, okay. And in the single stage machine, we stopped turning at day 14. Day 14 being the time that we know that as far as the turning in relationship to the purpose of turning, with it, keeping the embryo oriented, the embryo is already developed to a point to where it does not need that anymore. And we stopped turning again at day 14 in the single stage. Why don't we stop turning in there? We level the sixth position. In other words, when a sixth position is established in the multi-stage machine, it's automatically leveled. Okay. Some people have tried leveling the fifth position. I never did. That never really worked, because the resistance through the egg pack was lessened as relationship to leveling that fifth and sixth position.
I think sometimes when people level the fifth, to me, it means there's some other issues going on. If they're
Absolutely.
seeing benefits with leveling the fifth as well as
Yeah,
the sixth,
yeah.
there's probably some other issues.
Yeah,
going on.
yeah. And again, you can't correct an issue by establishing another issue. You know, it never
Yeah.
has worked. It won't work today. You know,
Right.
if you've got a problem, the problem needs to be corrected. Again, you know, how do you determine a proper turn in relationship to troubleshooting? You know, of course, in the single stage machine, if it don't turn properly, you'll get an alarm.
Mhm.
In the multi-stage machine, we had to manually check that and going down the aisle of the machine and looking and at 4 inches, you know, as you go down through there, is what we do in relationship to troubleshooting the machine. Okay. Anything else on turning you want to talk about?
No, there's just a couple questions on here asking about the frequency of turning. Can that be adjusted by flock and flock ages? I know in our platinum machines now, we can set it to do, say, 15 minutes for the first few days and then 30 minutes, 60 minutes.
Mm.
And then it'll go that way. Otherwise, in the multi-stage, you're gonna have to go and change everything
Yeah.
on there. So it can be done in
Mhm.
accordance with the
But you know,
group of eggs you have and everything. But
just remember this: the more frequent you turn, the more wear and tear it is on your buggies.
right.
So again, you know, you got to take that in consideration. As far as the 15-minute turning, we really didn't see an advantage to it. You know what I mean?
I think the more frequent turning affects if you don't have a proper turn angle, then you can do a more frequent turning early on, and that will help.
That will help.
But-
Yeah. But
But you
again,
should fix your turning.
you cannot correct an issue by doing something else.
That's non-standard,
yeah,
as you
right.
always said. That's one thing Jerry always said, not a standard hatchery. If it's non-standard, it's hard to fix a non-standard hatchery.
It is, you know, and some of y'all are bullheaded too. You know what I mean? Won't listen. and you try these things
I mean, you've probably been called that before.
well, yeah, we've probably been called that before too. Yeah. You know, and probably I'm a little bullheaded, you know, but you know, the machine is the machines, regardless of who manufactured them, they still need the basic stuff correct.
Right.
You know. Yeah.
Some of these things we already touched on, but
yeah.
just touch on the ones that we haven't maybe.
Okay, the airflow and turning, of course, we've already established, you know, if you've got buggies in the machines that don't turn the full angle, whether it be a 41 in the single or 45 in the multi-stage, 42 to 45 in the multi-stage machine, the airflow is affected as it transitions through the egg pack, as that air hits a resistance less than the other buggies, then it's going to speed up the air. And actually the position following will be the one most affected. Okay.
Yeah.
Again, turning angles, we discussed it, and I think some of the manufacturers turn their eggs at 38, maybe even 39 degrees.
Right.
And I think most recently determined, especially with the egg size and the different things that is confronting y'all out there, and as you need less resistance because your egg pack is creating more resistance, and by turning them 41 versus 45, it does free up that air and gives you a little bit more, what would you call it? A little bit more room for that larger egg to be in your incubator. Okay. Again, one of the questions here is, how do you identify a turning issue? Monitoring machines, you know, in the multi-stage machine, you will see a side-to-side variance in the temperatures if you got some buggies not turning on one side, you know, versus the other side. So the two sides, A and B side, however you want to say it, needs to be the same temperature. 100.3 24 hours after transfer, you know, at a 98.8 set point. Okay. So if your temperatures are different, one of the causes could be improper turning. Okay. turning out, improper turning. Okay.
One question that came up on the relation to this, and I was asking it, is about stopping turning in turkey eggs. Typically in avian eggs, we say the first 2/3 of incubation, they need to turn.
Mhm.
So in chickens, that's about 12, 13, 14 days.
Yeah,
In
yeah.
turkeys, that's gonna be around 19 days.
Yeah.
Maybe 20 days, something like that. So it's roughly about that first 2/3. So
Mhm.
yes, the question was, can you stop turning turkey eggs at 21 days? Yeah, you
Yeah,
can. You can
yeah,
actually do it a little bit earlier than that as
And the
well.
same-
But it's all good.
The same thing, in turkeys is, the same principle is applied in relationship as the need for turning is at the early stages is embryo begins to grow and as it begins to develop and on the top of the yolk. If it don't turn, then the egg will always stick to whichever side it's not, not turn or it's turned to and not turning. But same principle applies with turkeys, just just later,
Yeah,
just
a
later.
little bit
Like
later,
Keith
yeah.
said, 2/3 of the incubation cycle, which would be 14 days in chickens and
About 19, 20.
yeah,
something like that.
in turkeys. What did you say? Anything else on that?
No, we're good.
Okay, fan speed, and this is, of course, fan speed is going to be in relationship to we can actually profile our fans for different speeds in the single stage machine. But before we get to that phase of it, the importance of the fans are that's what creates or generates the air movement through the egg pack. Okay, which has the function of distributing the heat and humidity to each embryo as it should be. In improper fans in either of those systems but will be detrimental to your embryonic development. You okay to drink water?
Sure, yeah.
Okay, thank you.
Fix your voice a little bit. If you think about it.
What?
Fix your voice a
Yeah,
little bit.
I need to fix in there. In the single stage machine, we got a program by which we can set up the fan speed. And when I was in it, basically just a sort of a standard general fan speed setup would be 0 to 1 day, 100%. 0 to 7 days, 75%. 7 to 10 days, 75%. 10 to 14, 90%. And then the rest of the incubation cycle, we would put it back at 100%. That was just a standard speed setup. And we come up with that ideal because of the embryos, and what they needed, that 100% the first day is when they are getting that heat up,
So you're saying the embryos can talk to us and tell us things?
The embryo is telling you what you need.
Yeah.
What you need. And the embryo you can't expect it to develop properly if you don't do it properly.
Right.
Okay.
Yep.
Okay. And as far as the maintenance of the fans, just I always check the ECU and stuff on my single stage machines before I loaded them back in. That was a standard practice to just check and make sure that the fans was operating properly. And the multi-stage machine makes the same thing, we just need to maintain your fans. And we were just talking a little while ago and about the 360 program and how it could point you maybe to when fans was 80% used.
Right.
I mean, you need to notice you got to order some fans in order to
Because it's pretty important. Yeah, the fans.
oh yeah, the fans are not pretty. They're not pretty, but they are important.
Yeah, they're not pretty. Okay. Sorry.
Again, we've already discussed the main objective of the fans is to take the heat and humidity and give it to the embryos, each embryo the same. In other words, it should be the same top, middle, and bottom. The variable speed thing in the single stage machines is a function that allows us to vary the fan speed or the air movement in relationship to the embryo and what stage of development it's in. And just remember what we talked about before. There's going to be a percent early dead.
Yeah.
There's going to be a percent late dead, but that should not exceed in the prime flock, what, 5%?
Mm-hmm.
You know,
Total
Total,
about 5, yeah,
yeah.
5 to 6, yeah.
Ideally, that would be 2.5 early, 2.5 late. But what I've seen, it seems to be just a little bit more weighted toward the early, like it'd be 3 and 2
Yeah.
instead of a 2.5 and 3. Okay. Again, I think we've.
Okay.
Yeah.
I'm interjecting, getting you off kilter here, right?
Oh yeah, you worrying me to death. We, we talked about humidity being one of the basic inputs that the embryo needs. Humidity's impact on incubation, just a simple statement that I used to make. If the humidity is too high, in the first 19 days or in the incubator, what you'll see in your hatch is you'll see a mushy or a soft albumin. You'll see a larger chick, but another thing you'll see is your hatch will be slowed down in relationship to the high humidity. The low humidity in relationship, what you'll see is sort of the reverse of that. You'll see a dehydrated chick. The shanks will be a different color and real dehydrated. You'll see a hard albumin or a hard navel. And again, it can be detrimental to your chick quality. In other words, what I'm trying to say is humidity impact on incubation relates to chick quality, and also it can relate to embryonic mortality, but what I've seen in that during what time that I was in the industry, that would you see a mid-dead increase, and you shouldn't see virtually nothing, in the mid stages. Okay. Moisture loss is a question that we've worked with over the years, and I think the old standard, and probably still works for us, is 11 to 13% moisture loss in the multi-stage machine, because multi-stage machine generally has an average of different ages of embryos in it, so the average moisture loss will be 11 to 13%, equating to a medium or a means of 12%. If I remember right, in single stage incubation, on smaller eggs, we was looking more at a 9% keep. Prime eggs.
Yeah, in a single stage.
Yeah, single stage. And on prime eggs, we were looking maybe at 10 or 11%.
Yeah.
And then on older flocks, that 13, 14% wasn't uncommon. So again, your moisture loss related to your what embryos that you're talking about. And very important when we talk about humidity, that the room ventilation be proper. We was talking about an instance where the humidity was real high in the machines, and when they went in more than regular, more than normal, and it washed the floor.
Yeah,
that would bring the room humidity up. Where does that air go? Goes right into your intake of your machine.
So you're saying that the hallway humidity temperature is pretty important.
It is absolutely
the machine
important.
run, right?
Yeah. You remember we talked about the machine needs proper water, and that,
Mhm.
and of course humidification is water. You know what I'm talking about? So again, humidity is important. If you ranked it, how would you say which of the four things that we talked about, heat, humidity, airflow, and turning, is the most influential in the incubation cycle? what would you say was the most influence? Okay. I would start with heat.
Yeah. Cause it starts the whole
It
process.
starts the whole
You can have a
process.
bunch of humidity with no heat and it's not gonna do anything.
Heat kills.
Kills and starts.
It kills and delays. In other words, if you got not enough heat,
Yeah.
it delays your hatch. If you got too much heat, you know, it'll accelerate and of course cause a lot more embryonic mortality. And so again, you know, very important that your ventilation be correct. I remember that probably at the first of my career with Jamesway, that was a major problem of ventilation. You know, people did not understand, I guess would be a word to say the importance of proper ventilation in a you know, in the room, and how it impacted the embryos inside, you know, the machines. Yeah. Again, we talked about that one. Oh,
Yeah. I'm throwing you out of whack again.
Yeah.
We've already discussed
yeah,
it.
yeah. One question that comes up is how often should moisture loss be evaluated? I evaluated moisture loss at every hatch in relationship. I'd look at the egg shells and establish where the pip line was. And if I remember correct, we wanted that embryo to pip about from the air cell, which is a large end of the egg, we wanted to pip about a third of the way down to make that pip all the way around. And then when that embryo pushed out, you know, it had the largest area to come out of, and it also was the correct 11 to 13 and all of the things that we talk about in relationship to the quality. Another evaluation that's pretty good to do is just pick up the eggshell in the hatch tray and crush it. You know, if it's real brittle, you know, indication that humidity was low. If it's like rubber, it might be that the humidity is too high. So somewhere in between rubber and just disintegration or real brittle is what you want. And look at the pip line; it should be about a third of the way down. You know, can be evaluated as often as you look at a hatch. You know what I mean?
You can almost not evaluate it too often.
Yeah,
Whatever works.
Yep. I think we've got that.
Here's an interesting question you can touch on real quick.
Okay, what is it?
How many the normal amount of maintenance personnel for a hatchery? I would say as many as you can have.
Let me just tell you this about maintenance. One good one is worth 5 bad ones.
There you go. Yep.
I mean, it depends on what you're talking about and how much money you're willing to invest in your maintenance program to get a good one.
Yep.
A good one can direct, depends on the size of the hatchery, two to three more, whatever. Depends on the size of the hatchery and what you're talking about.
But you're right about that. A good one is
a good
gold.
one. A good one is worth 5 bad ones.
Yeah.
You know. Okay. That's
Yeah. Go ahead.
yeah. Okay. The next thing we was going to discuss was profiling, and profiling, of course, talking about the single stage machine. But before we talk about the single, let's talk a little bit about the multi-stage machine. Although the multi-stage machine does not work on a profile as such, if you'll do the entrance in temperature as you should, the internal and fur leg temperature in the 5th, 6th position as you should, and if you'll get your pressure inside the cabinet correct, that's really like a profile in relationship to the multi-stage machine. Okay. But profiling in the single stage machine is you create the parameters by which that machine operates in relationship to heat, humidity, and damper. You know, that is all profile. Okay. So again, you know, you set the parameters as needed in relationship. What does embryos need at the beginning? What do they need at the end? And what did at the beginning, middle, and end? And just go for example, the early embryos need 100.3 to 100.4 degrees Fahrenheit inside the egg, you know, as they start that development. As they go into the next stage, the average incubation temperature that we used to work with was about 99.5. In other words, right in the middle, you know, in that, what day we're talking about, 14, 15,
Yeah.
you know, we wanted that average to be at 99.5. And then as it got toward the other, the exothermic stage, we would drop that temperature down to as low as like with the high yielding breeds. I remember dropping it down to like 97, even some 96.5 with some of the higher heat producing breeds that we had. And that's all I'm gonna say about that. You know, the heat producing, we had breeds that was proven to produce more heat. And as a result of that, we had to alter our profiles in relationship to which breed that the company had. And we had profiles for Cobb, we had profiles for Ross, you know, both of them.
Profile for layers.
Layers had profiles for breeders. That's, you know, a little bit the fertility and stuff is embryonic heat and primary, as you know, is usually the fertility is pretty low. The hatch is low. So again, and we evaluated that and come up with some profiles. I don't know exactly what everybody's using now. I'm sure it's some tweaking. That's
Very similar to what you started working with developing, but the art of incubation has allowed us to tweak things a little.
Absolutely. The nature of the single stage incubation allows you the opportunity to adjust as you see a need to adjust in relationship to the challenges that the input of the egg is causing. That way to say that. Okay to say it like that. Okay.
Yeah, and I will just throw in when you talked about the different temperatures, you know, from early to late. When we say our profiles are like 97.5 or something like that, that doesn't mean that's the temperature we want the embryo to be at or the developing chick. That's the temperature we need to get enough heat out of that egg so the embryo is at that, or shell temperature is at that 100.1 or something. We just have to have a lower air temperature, but we're not trying to make the embryo itself be 97.
Look at that like this, and I've actually done this before. Once you achieve 100.3 inside that egg, that's a pretty good temperature to achieve all the way through. I'm talking about inside the egg.
Yeah.
You know, what happens is the outside temperature controls the inside.
Yeah.
You know, so as that embryo starts out endothermic, that 100.3, 100.5 is what that embryo needs, you know. But the embryo temperature as it goes through development is pretty well constant.
Yeah.
You know, now it'll drop a little bit in the neutral stage. It'll drop down to maybe, I've seen it drop down to like 100.
Yeah.
You know, but then at the end, I've seen it also jump up to 100.5, 100.6.
Because we're pulling a lot of heat out of them.
Absolutely.
And that heat exchange.
Absolutely. So all of that is considered as you evaluate and you profile and you make adjustments, you know, for what, not breed in particular, but what kind of hatchery in relationship to broiler, breeder, layers,
turkey,
duck,
whatever,
you know, all the profile. But again, basically, that's just always remember, let's go back to the basics. All the embryos need heat, humidity, airflow, and turning. With the profile, you establish the parameters that the machine operates at, and if the profile is correct and the machine is operating correct, you know, then your hatch will be correct in relationship to quality. And again, one of the number one things that puts the meat to the processing plant, like we talked about at the beginning, is a good, not a good, but a what's gooder than it's a gooder, sorry about that. You know, a gooder.
Better than good.
Better than good chick quality. In other words, the better chicken you put out there, the better it's gonna grow, the better it's gonna convert
Absolutely.
feed, and the more pounds you're gonna put in to the processing plant at least cost.
Yep.
All that is what it's all about.
Absolutely.
I've heard people talk the hatchery is just a liability, you know?
It's a liability that's gonna get you started right or wrong.
Right, but it's a liability, but companies with that attitude, a lot of them has changed because they understand
Right.
that a good quality chick will make them money.
Yep.
So money vested into the hatchery to upgrade and stuff, it pays off. It costs a little, but it pays off in the end.
Yep.
Okay.
For sure.
Okay. Anything else you want to
Yep.
talk about? This is just an example of a profile, and when Keith showed me this profile, it's one that was made back when I was still in the industry.
You
'Cause
probably did it.
I think I did this profile, you know, but if you'll notice, where's my little thing?
There it is. There.
Yeah. Here you see up the holding mode, 6 hours before. In the single stage machine, the profile brought the egg pack up to 80 degrees. Okay. Now, the purpose of that 80 degrees is it comes out of the egg room at 65-degree holding temperature in the egg room. But what we noticed in the egg, all of the eggs don't come out at 65 degrees. The purpose of this pre-warm is to get all the embryos warmed up to that 80-degree temperature, and then 3 hours before the profile starts, it goes to 85, and then we start the profile at 100.4, and as it goes on down through, and we come right here, day 12, we've got a, where's my thing? Day 12, we've got that 99.5, and go on down, and at the end, at the 18 days, we've got the temperature all the way down to 96.8, you know, and all of that, just remember, it's for the embryo. And what we want to maintain in relationship to that is we want the inside of that egg with these temperatures to maintain, or not, once it obtains, we need to maintain that embryo temperature as constant as it can be as it goes through the process, you know, okay? And I think this shows a pilot profile, or is people still using pilot a lot or not, or no?
Yeah.
Yeah.
But some use it to actually run their machine, some use it to monitor and upgrade profiles and stuff.
Yeah. But again, this would be your profile for your this would be your profile for your eggshell temperature. Notice it pretty well remains that constant, you know, and what that's doing is the same thing. It's measuring the temperature of the shell, which relates more closely to the embryo temperature, you know, because it's right there on the shell, and it should remain pretty constant throughout the incubation process. And then the humidity, you notice, is high for the first 9 days because that's when the damper is closed. We really weren't concerned about how high that humidity went in the first stages. You say, well, what about your moisture loss? You get your moisture loss as the damper begins to, as the damper opens and begins. Now, if you got a high room humidity, what's going to happen to your moisture?
Yeah.
It's going to maintain a higher level. It'll never get down to 30% at the end.
Right.
Okay.
Question on this, on the holding period, is would that be different for like layers or broilers? Or eggs, if you got any egg age?
Again, the primary purpose of the pre-warm, as we first started doing it, was to take the eggs out of the egg room and get all the eggs up to a temperature in 6 hours, you know, And, you can, you saying, is the difference in the breeds different in the,
Would you like do something different there for different layers or broilers?
I mean, yeah,
Typically not. I don't know whether
typically
you-
not, I don't think you would, but specifically, if you had a need, you could, you
Yeah.
know what I mean?
Oh, yeah,
You know,
sure.
if you had a need, you could like egg holding. You know, if you was holding your eggs for extended period, typically you would turn down your egg room temperature.
Mm-hmm.
So the eggs coming into that incubator with that extended storage time, the inside of that egg would be cooler.
Yeah.
So I might extend it in that case. The single stage has so much flexibility in relationship to what you can do,
Right.
not what you can do for the embryo in
Mm-hmm.
relationship to the different concerns or the different challenges presented. Okay. Again, I think we've talked about how to design a proper profile.
I thought it was interesting when you told me you kind of used what's happening in the multi-stage.
Oh, yeah,
The
yeah.
temperature we go in there, that's a starting point for a profile.
Absolutely. You start out and, you work with the multi-stage. We knew that the 100.3 coming through the egg pack at 24 hours after transfer, we knew that this egg would take it in an infertile egg in the 5th or 6th position. And the infertile egg just represents, I always tell them, it's like a cup of water sitting there,
Yeah.
in relationship. So that temperature should be your set point at the top. And the nature of the Jamesway multi-stage machine was it'd be a little bit warmer right in the middle. It'd be 98.9 to 99 in the middle and 98 to 8 at the bottom. You start with that and, you think, well, what's going on here? So you start taking some infertile temperatures in there and you find out, hey, this is pretty good. You know what, it gives you a starting point of 100.3, 100.4, 100.5, depending on, what you want to do. And then you remember your average being 99.5, sort of plug that number in, and then your end, you can get that cooling for the heat generated embryos. Okay. Okay. Anything you want to talk about?
No, we're good.
Okay. Machine multi-stage pressure. This was one of the things that some of the old guys, the Jim Collinses, I don't know if any of y'all remember him, Lynette Price, and different ones that we began to discuss this incubator pressure. Multi-stage incubator pressure. And what I found out in working with this was if you got that pressure correct, your embryonic development would be, your temperatures would be much better throughout your egg pack. Okay. So the importance of that pressure is absolutely critical, and the measurement, we used what was that thing called? Manometer to measure the pressure. And I'll show you in just a minute how that's done, and the reference points and how to adjust it, and it's unique in our multi-stage machine, but yet it is, if you'll do it, you'll see an improvement in machines. Okay.
Right.
Now let's look, what in the world?
You got fancy with animations.
I don't know what that is. Okay. And what we determined was the negative pressure in the Jamesway multi-stage machine should be 60%. The positive pressure should be 40%. Okay. So what does that all mean? Okay. The 60%, in other words, as the picture of the Jamesway multi-stage machines, the fans are up here and they're blowing over the rack. Okay. And that air is given to that 5th or 6th position, and it's a positive pressure. The output of the fans is positive, but is that air is given to the fifth and sixth position, that pressure changes to negative. So the air is drawn through the egg pack. So one way of looking at it is the front side of the fan blade pushes, the back side of the fan blade draws. Okay, so what causes it to be altered? The damper adjustment, squareness, or air leakage at the doors will cause the pressure to be altered. Example being, if the negative pressure is more, like the negative pressure being 75% and the positive pressure being less 25%, it means that there's more exhaust than there is intake, which means the exhaust damper more open than the intake damper, or excessive air leakage at the exit end doors. Okay. If the negative pressure is less, if it's 40% and the positive pressure is 60%, the ratio means that there's more intake than exhaust. So it would be the intake damper more open than the exhaust, or excessive air leakage at the entrance end door, which you cannot allow air leakage at the entrance end door, because that air is sucked into the machine and it'll cause all kind of problems in relationship to your side to side and your entrance end temperatures as that air is generated. Okay. We don't talk about this. Okay. And that's all we got in relationship to the formal presentation.
I got just a couple of questions. We don't have a whole lot of time left here, but just to let you know, any questions that you've asked that we did not get to today for some reason or another, sometimes they're very specific. And so we'll address them to you directly later in an email, just so we can, answer your question exactly how you want it. You've been all over the world, I know, heard all your stories. What kind of thing would you be a strategy for improving like chick quality in places like Africa, or in relation to like power supply and maybe less technology or something? What are some strategies or things that you've seen?
Again, the strategy that I always try to emphasize is get your basics correct, or as correct as you can in some places.
Mm-hmm.
And then you have to know how to adjust for non-standard things that you cannot, get that you do not have the proper machine input.
Yep.
But it don't matter where you are in the world. There's a couple of things that you need to understand. The basics of incubation does not change. Okay. The need for proper maintenance, way I always stated, was any hatchery, regardless of its size, location, is no better than its maintenance program. Okay.
Absolutely.
So no matter if you're in Africa or no matter where you're at, you can still have proper maintenance. Okay. And you can have proper inputs, okay.
In wrapping up here, I had some nice comments from some friends that we've known for years.
Is that right?
Oh, it's good to see you guys talking, having fun together. So anyway, we'll talk about that later.
Yeah.
But what would be the problems of somebody trying to use an incubator, whether multi-stage or single stage, is both a setter and a hatcher?
First of all, it would not work in the cycle because
multi-stage especially
multi-stage you couldn't, because when they start hatching, what you gonna do with them?
Yeah.
So
what about single stage?
Single stage, same thing. What are you gonna do with them if they hatch?
Well, could you take the machine then and just put hatch baskets in it and put them back in it?
You could.
Yeah.
You absolutely could.
Yeah.
But what you got to remember
single
is
stage, multi-stage.
No. But single stage, you could do that. But also you got to remember, your cycles, and it's an 18-day, 19-day cycle for the incubator, and then you load it back. So it would cut down on your, not efficiency is not the word, but cut down on the number of in other words, you'd lose a cycle over a period of
Mhm.
time,
Yeah.
which would be that, cost you money, okay?
What if they said, what if somebody's got eggshell temperatures that are off by like 0.2 degrees? How is that gonna affect our incubator temperature? And do you, like in a multi-stage, do you have different set points for
Well,
prime egg, young,
yeah,
or old, whatever?
In the multi-stage?
In the multi-stage, yeah.
What I used to say was for every 10th degree variance in that temperature, you could expect, well, 1 to 3 hours, 1 to 2 hours difference in your total incubation time.
Yep.
Okay, so if, in other words, if it's 2/10 too high, your hatch will be accelerated. If it's 2/10 too low, your hatch would be slowed. Okay,
And I've seen some profiles that you've developed over the years to where you actually have for different fertility levels. So
absolutely.
your fertilities come down, then you need to make adjustments to
Right.
that because you don't have the heat from all the embryos.
But you can actually, what you can do with the profile is you can actually slow it down in the endothermic stage.
Mhm.
Because it's gonna catch up in the exothermic
Yeah,
stage.
yeah.
With the different
Yep.
fertilities and stuff, you see? Okay, so,
Yeah.
so again, it's all in the, I guess one of the closing things we could say is, know your egg pack, know your machines, know your hatchery.
Mhm.
Every hatchery I've been in, it has a little bit different. But when I go in it and I walk out of it, I want it to actually have the basic stuff the same.
Yep.
Okay.
Great. This has been enjoyable, Jerry.
Well, thank you.
We've been jabbing at each other a lot over
Oh,
the
yeah,
years.
yeah,
This
yeah,
is kind
yeah,
of fun to do
yeah,
it here.
yeah,
Hope it wasn't too annoying to people that
Yeah,
we got in and jabbed each other a little
yeah,
bit, but
yeah,
it just goes back to what we've done.
absolutely.
But I appreciate all your expertise and knowledge and everything that's done. You've meant a lot to Jamesway over the
Thank you.
years
Thank you.
and what we have. So very glad to have you here as a speaker. So again, for those questions that we didn't get answered, we'll get to those specifically to you. Like some are a little bit specific, but other than that, thank you everybody for coming. You can tell other people they can come and look at any of our webinars on the website, Jamesway website. We have close to 100 now recordings of different webinars over all the different topics. So
Good day.
so anyway, thank you all for coming and participating in our webinar, and we hope to see you again at another webinar at some future date. So thank you.